there's a title. How the heck do you solve a polynomial equation? The first thing you got to do is to put your phone away and take your earphones off, right, Rhea? So you're the man. The second step, here we go, I'm going to give you the steps. Step 1. Factor one side of the equation completely after you get one side equaling 0. Step 1. Factor one side of the equation completely after you get the other side. I should say the other side. After you get the other side. There's only two sides of the equation, right? So the first step is factoring one side after you get the other side equaling to 0. Step 2. Set each factor equal to 0 and solve for the variable. You will have multiple solutions most of the time. Done. Two-step process. Write that down. Factor one side of the equation completely after you get the other side equaling 0. Step 2, set each factor equal to 0 and solve for the variable. So put solve for the variable. You will have multiple solutions most of the time. In other words, you won't have just one solution. You'll have more than one solution, like we did a warm-up. Some of those had more than one solution. Let me elaborate. Nice. Pour some coffee and we're ready to rock and roll here. Okay. Let's do it. Example 1. Solve for Q. Look at this equation I'm going to throw at you now. Look at this equation. Watch this. Solve for Q. Q to the third minus Q squared equals 30Q. You didn't see those kinds of equations in Math 1. You didn't see those kinds of equations in Math 2. But congratulations, you've arrived. You're in the big leagues now. Let's do step 1. Factor one side of the equation completely. When I say completely, I'm talking jujitsu. Use every single method here from our 7 methods. But it says after though. Don't even do that till you do this. Till you get the other side equaling 0. Let's look at this equation. How can I get the right side equaling to 0? What would I do to both sides to get 0 on the right side? Let's get rid of this 30Q on the right. What would I do to both sides? Q, huh? Rocking and rolling. Look at. If I subtract 30Q from both sides, look what we get, ladies and gents. Do this with me. Look what we get. Observe. Ponder. 30q minus 30q is 0. That's what we want. That's what step 1 says. Get the other side equal to 0. Over here, what's q squared minus 30q? Don't bite the bait. Don't bite the trap. What's q squared minus 30q?
Isn't it just q 3 minus q to the 30 minus q?
Why? Thank you. Can you say it a little louder, the last word? I think so. Say it louder, the last.
Because it's not like.
They're not like terms. Look at this q to the second, this q to the first. You can't combine them. Think about a month ago when we did adding, subtracting polynomials. You can only combine like terms. So look what we got. We end up having a trinomial on the left. Check it out. Q to the third minus q squared minus 30q. Look at that. 2 stand for you, Bass. You say the day twice already.
You over 3.
3? Okay. Since he said it, I got you. 3. Let me scoot this over. So look what we got. We got 0 on one side, and we have a trinomial on the left. Step 1 says, factor this puppy completely. Jiu-jitsu time. See, you already know how to do this. You just weren't aware of it. I've been setting you up this past month with all the methods and tools to be able to solve polynomial equations. You already know how to do it. You just you're not aware of it. It's kind of like a Karate Kid. Have you guys seen the original Karate Kid? Daniel LaRussa? Classic. Okay, watch this. Watch. That's each day, not knowing why I'm having to go through this torture. And now, you guys are in a position to solve for this equation. I'm Mr. Miyagi. You guys are Daniel. You guys are Karate Kid.
The only difference is that you want to learn it before you want to.
I think you're on YouTube too, saying that. Did you record that? Let's see. Yeah. Thanks for ruining my parade there. All right, here we go. What tool are we going to use for this equation? Q to the third minus q squared minus 30q. What tool out of the 7 can we use to factor that puppy on the left?
When a equals 1?
Let's notice, always go here first, huh? GCF? So what's a GCF? Q. Rocking and rolling. Let's do it. Q. We're still on step 1. We're going to factor the left side only. Q times what is q to the third? Q squared, huh? Q times what is negative q squared? Negative q. Q times what? Negative 30, huh? Equals 0. Let's keep going. Okay. Think Karate Kid. What method now? Inside the parentheses. I got a trinomial. Help. Trinomial. Help. A equals 1. Trinomial A equals 1. So let's get the 2 binomials ready to go. Let's not forget the q. That's going to come in our final factorization. I need 2 numbers that multiply to become negative 30, but added to be negative 1. Look at the B. Multiply to become negative 30, added to be negative 1.
6 times negative 6 times 7.
I think you got it. Look at this. Minus 6 plus 5. Look at negative 6 times 5, negative 30. If you add these up, it becomes negative 1. Beautiful. We factored completely. Look at what step 2 says now. Look at step 2. Set each factor equal to 0 and solve for the variable. You'll have multiple solutions most of the time. Not all the time, but most of the time. Let's see. I'm going to set each factor equal to 0. What are the factors? Well, Q is a factor. Just on this example only, let's underline, or let's put an arrow to the factors. Q minus 6 is also a factor. And then Q plus 5 is also a factor. Remember, factors are stuff you multiply to get to other stuff? If I multiply all these factors out, I'll get the original expression. So step 2 says, set each factor equal to 0 and solve for the variable. Let me set each factor 0. Watch. I'll put it in red now. So you see that I'm shifting gears now. Every factor I'm going to set equal to 0. Excuse me. I'll set that factor equal to 0. Look at Q equal to 0. Well, that was easy. There's a solution. I know one of the solutions is 0. I'll put a comma. How about Q minus 6 equals 0? Look at this. Q minus 6 equals 0. Comma. And then Q plus 5 equals 0. I have these really dirt cheap. I have 3 easy equations to solve for. I'm talking equations so easy, that's like before Math 1. That's like junior high stuff. I took each factor, set it equal to 0. Look at it, it's right in front of you. And now I'm going to solve for Q on each equation. First equation, Q is already solved for. That was easy. Look at Q is 0. There's a solution already, right in front of your face. How do you solve for Q here in the second equation? Thank you. Add 6. This is middle school stuff. Look at by Q is 6. There's our second solution. Third solution. How do you get Q by itself over here? Both sides, huh? By Q is negative 5. Here's our solutions, ladies and gents. We have 3 solutions to this equation. Right, Reyes? I'm losing you. I'm showing you jujitsu. Come on. 3 solutions. Go to write solutions. And put an arrow at the 0, the 6, and the negative 5. Believe it or not, if I replace Q with those numbers, it'll satisfy the equation, the original equation we started off with, this polynomial equation. So it's a big setup. I set you up, just like Daniel LaRusso was set up by Mr. Miyagi. You guys know how to do polynomial equations. Most teachers in Pomona Unified, let alone California, can't do what you just did. Believe it or not. Let's try number 2. Question number 1. Let me recap. What I do, I got 0 on one side by subtracting 30Q. Step 2, well, it was still step 1. I factored completely the left side. And then step 2 was I took each factor, set it equal to 0, and I got my solution. There's 3 of them. That was easy. 2 more examples quickly. Here we go. Let's try. Here we go. Here we go. N cubed plus 2n squared minus 9n minus 18 equals 0. What the heck? What in the world is going on here? Let's do step 1. See, step 1 says factor one side of the equation completely after you get the other side equaling 0. Is one side 0 already? Yeah. Right, that's beautiful. So this factor left side. I think I heard grouping. Right, there's no GCF. The only game in town then is factored by grouping. 3 days ago, I think I taught you that. Let's group this puppy. First group, second group. GCF from the first group. I want to say the GCF would be n squared. Yes, Ms. Johnson? No problem. Anytime. What's left over? We got n plus 2. Rocking and rolling. They bring down the minus. Careful. Look, we got a minus between both groups. Keep that a minus, please. Thank you. All right. GCF here, I want to say is right. Look at that. N plus 2, yeah? Negative 9 times 2 is negative 18. Rocking and rolling. We're not done yet. Let's not get all happy. We now got to extract the same binomial from both groups. I taught you this already. All right? So our final extraction, I'll take out the n plus 2 here and the n plus 2 from both groups. So I have n plus 2 times whatever's left over from both groups. Help. Nice. Or n squared minus 9. Same thing. Very nice. Equals 0. Am I done? I heard a no. I'm going to give black belts to those who said no. McNair, why are we not done? I see something. What do you see? I can go further, right?
Yeah, you go.
Tell me where. I'll give you a black belt right now.
Maybe because I don't know.
Oh, you're there.
Maybe because of anything.
Okay, well, let's see. I'll come back to McNair. I'll hit it. Black belt right now. So, like, multiply?
Yeah.
Well, if I multiply, I'll start getting back up here to the original expression. We want to keep it factors. I heard somebody over here. Hit it. Black belt. I got a black belt right here. I'll get to you later. I need some. There's the two squares. Look at the second binomial. That's a difference of two squares. You're the man, Esquivel. Watch this. Something squared minus something squared, right? Let's factor this. It's a difference of two squares. My A would be n. My B would be what? Careful. What's my B value? 3, huh? For the pattern. So the pattern says A plus B, A minus B. N plus 3, N minus 3. And don't forget the N plus 2 over here. I think we've factored it completely. There's nothing else. Now step 2. Step 2 says, set each factor equal to 0 and solve for the variable. Let's do that. I have 3 factors here. There's 3 binomials.
You gotta do all of that for one problem?
No, you can just fail and take me over.
Damn.
So you don't. So to answer, you don't have to do any of this.
That's a lot of work for one problem.
No, just take me over.
They're all zeros.
They're all different.
Ready? Let's take each factor equals 0. Watch this. N plus 2 equals 0. N plus 3 equals 0. N minus 3 equals 0. We're rocking and rolling. Let's get n by itself. This is like elementary school, I think. They introduced you with equations first. Way back in whatever elementary school. You did simple equations like this. So let's get n by itself. We'll subtract 2 here. Look at n is negative 2. There's your first solution, comma. Here, let's subtract 3. N is negative 3. There's your second solution. Last but not least, let's add 3 to get n by itself. N is positive 3. Here's our 3 solutions, ladies and gents. Awesome. Now, I underestimated how much time it would take to get into this type of material.
Oh wait, there's a way.
Hit it.
Right.
No, they're actually not. RT's had me too long already. He's awake. So we're not going to do the pattern today. We only have about 15 more minutes of class. Use that time to finish up 18, 19, or 20, or 21. We'll continue this on Monday. Notice what I said, Monday. This will not be on tomorrow's test. Oh, shoot.
Can I use the restroom?
Hold on. You guys are all on YouTube here.
I'm gonna wait.